Hello, Cloud Speed is your gateway to AI and cloud innovation. Stay updated with the latest trends, master new tools, and gain practical skills to develop the next big thing. This series explores different ways to host open source models in the cloud. As always, we keep it practical and hands-on. Today, we're deploying an open source model, specifically Deepseek, on an AWS EC2 instance. We'll be using the Deepseek 7B model, one of the smaller models in the Deepseek family. There are multiple ways to access AI models, for example, through AWS Bedrock, Google Vertex AI, Replicate, Baseten, OpenAI API, Hugging Face, and others. Similarly, there are different ways to deploy an AI model on compute infrastructure, such as EC2 instances, EKS clusters, and containers. In this video, we won't be using a GPU-enabled instance. That's something we'll explore in future videos. So, let's get started. We've created a short, easy-to-follow guide on how to do this. Just follow the steps in our documentation, just as we'll demonstrate here. First, we need to create an EC2 instance. We'll use an R4.2's large instance. Let's head straight to the AWS Management Console. I'm currently logged in as an administrator. My default region is US East 2, and I'm on the EC2 dashboard. Let's create our EC2 instance and name it Deepseek. Next, let's create a key pair. Name it Access, or whatever you prefer, and it will be downloaded to your computer. Oh, I almost forgot. We need to select the instance type. For this task, we need an instance with high RAM. We'll use an R4.2's large instance, which has 64 gigabytes of RAM and 8 MTPS, but no GPU. The Deepseek model requires at least 10 gigabytes of memory to run. Keep in mind that this instance is not free tier eligible, so you will be charged for usage. As outlined in our documentation, we need to configure the security group to allow traffic on ports 80, 443, and 22 for web and SSH access. Set the storage size to 20 gigabytes. This ensures we have enough space to store the model data, which is about 1.7 gigabytes. In the comments section, I've shared a link to a GitHub repository containing the necessary files for running the model. You might only need to modify a few properties, such as the domain name or the model type. Now, let's copy the files to our instance. If your instance has been successfully created, open it and copy the IP address. Next, open the file in your code editor and use the command to transfer the files from your local computer to the EC2 server. Remember to update the IP address and key pair file directory. Now let's check the files we're transferring. Docker file creates a container using the Ollama/Ollama image. It includes a script, start ollama.s, that starts the Ollama server, waits for 10 seconds, and pulls the Deepseek R1:7b model. The script is made executable and set as the container's entry point. Dockerfile_Ollama builds a container using Python 3.10, installs dependencies from requirements.txt, copies the FastAPI application files, exposes port 8080, and runs the FastAPI app using Unicorn. FastAPI_Ollama, a FastAPI application that provides endpoints for text generation, health checks, and model listing. It logs requests and responses, handles errors, and communicates with the Ollama API. The app runs on port 8080. Traefik configuration sets up Traefik as a reverse proxy. It configures HTTP, port 80, HTTPS, port 443, and lets encrypt SSL certificates and enables the API dashboard for monitoring. Docker Compose files. Docker Compose.yaml defines a service for the FastAPI application, builds the app, ensures automatic restarts, and configures Traefik for routing and TLS. Docker Compose tf.yaml configures Traefik and FastAPI, managing SSL certificates and routing traffic. Docker Compose ol.yaml sets up two services, Ollama for model inference and FastAPI for API access. Now, let's fix our directory structure and organize the files properly. Clicking the Send button will begin copying the files to our instance. Type Yes to confirm. Now let's check our progress. Next, we need to SSH into our instance. Copy the command and update the IP address and key pair file directory. Now that we've accessed our instance, let's list the files to confirm they were copied correctly. Connecting a domain to the instance. To link your domain to the instance, copy your domain name. I have a domain registered with GoDaddy, so I'll update my root domain to point to the EC2 instance's IP address. For Windows users, open PowerShell. For other OS users, open a terminal and confirm DNS propagation. Our DNS settings are now routing traffic to the EC2 instance. Installing Docker and Docker Compose. Now we need to install the following: Docker, Docker Compose, After installation, confirm Docker is running. Exit your shell, then log back in to apply the necessary permissions. Start the Docker containers accordingly, then run Docker ps to verify that they are running. You might need root privileges to run the command. Testing the setup. Test the program from the command line using your domain name to confirm everything is working properly. We should see the message. FastAPI is running. Now let's check our FastAPI underscore Ollama.py file. We are using the Deepseek R17B model. The earlier message appeared when we accessed the root domain. To interact with the Ollama container, we'll use the /generate API route. Now, let's send a test prompt. Say hi. This response takes a while to generate. There are two possible reasons. We are using a non-GPU instance. The model performs multi-step reasoning before generating text. The think indicator shows that the model is reasoning through a chain of thought before responding. Front-end, langchain, and streamlit. For our front-end, we are using langchain and streamlit. Langchain is an open-source Python framework that simplifies interactions with large language models, LLMs. While we are using a custom API, langchain can also connect to models from Anthropic, OpenAI, AWS Bedrock, Baseten, Replicate, Google Vertex AI, and more. Streamlit is a Python-based framework that makes it easy to build dynamic UI components with minimal code. This Streamlit app creates a chatbot interface using langchain's LLM. It initializes session storage for chat history, accepts user input, sends it to the LLM, processes the response, and displays the conversation history. We removed the think tag from the API response to ensure clean text display. Now let's test the application. The UI looks great. However, the chatbot is significantly slow. To improve this, we'll try a GPU-enabled instance in our next video. Cleaning up. Once done, delete your EC2 instance and other resources to avoid unnecessary charges. If you found this video helpful, give it a like and subscribe to CloudSpeed for more updates on AI and cloud technologies. Check out other videos in this series to explore different ways to host an open source model.